Launch. Sequencer reset. Launched. Ignition. Guidance on, we are supersonic.
The X-43 project, this project was done in the mid-2000s. We were able to fly at Mach 8 and then Mach 10, which was a project that tested a subscale model, unmanned vehicle whose objective was to be able to fly at hypersonic speeds using an air-breathing engine instead of a rocket engine. We've been flying hypersonically with rockets for a while, sending them into space and etc. But using an air-breathing engine to be able to fly at those fast speeds. And so we still hold the Guinness Book of World Records for that. So right now we don't have an engine where we can start on a runway and then get to those hypersonic speeds all with the same engine. And so this vehicle was mounted on the front of a rocket that was slung under a B-52. And so they flew up to altitude, they launched the rocket, it accelerated to about Mach 4, Mach 5, and then it separated from the X-43 vehicle. They lit the engine on that vehicle and it accelerated. So we did a lot of wind tunnel testing for that vehicle. So my name is Hubert Senter, and everybody calls me Bert. I'm the facility manager for the Scramjet Test Complex at the Langley Research Center. I've been working roughly in the same speed regime, hypersonics, since '87. Currently, I'm the facility manager of 2 wind tunnels, the Scramjet Test Facility and then the Direct Connect Subsonic Test Cell 2 is what we call it, Direct Connect. So. Hypersonic, in layman's terms, is Mach 5 and above. And the reason we're interested in it is because the flow physics changes from slower speeds. I know you hear a lot about Mach number. So Mach number is the speed of the vehicle divided by the speed of sound. So it's very important to us that we're testing at the correct Mach number. Anything less than Mach 1 is going slower than the speed of sound, and greater than Mach 1 is faster than the speed of sound. The speed of the vehicle is also dependent on where it is in the atmosphere, because as you go higher in the atmosphere, the speed of sound decreases. The denser the air, the closer the molecules are together. And so when a sound wave propagates, if the molecules are closer together, they vibrate each other faster. There are more of them. The distance between the two are less, and so it can translate that sound wave faster. The air density is highest at sea level, so that's where the speed of sound is fastest. A vehicle going 1,000 miles an hour at sea level is going to be 1 Mach number. If it's going 1,000 miles an hour at 100,000 feet, that's going to be a very different Mach number. And the reason we like Mach number is because it's an indication of how compressible the flow is. And I know probably on movies and things like that, you've seen things that go faster than the speed of sound. They have a shock wave around them, right? Like a shroud going over the thing. The higher the Mach number, the closer that shock wave is to the vehicle. When you go through these different speed regimes, subsonic flow, less than Mach 1, the air has certain characteristics. But when you pass the speed of sound, the air behaves differently, basically because it can't get out of the way. When you're going less than the speed of sound, the air, it kind of knows that something's coming. When you're in a boat at very low speeds, you can see the ripples in front of the bow, right? When you're going faster than the speed of sound, your boat or your vehicle has caught up to those sound waves. The air doesn't know that this vehicle is coming. And what happens is the air it compresses a lot, it heats up a lot. And as you go higher in Mach number, it heats up even more. And when you go at about Mach 5 or 5 times the speed of sound or higher, you're imparting so much energy to that air now. The molecules are starting to vibrate, so it behaves even squirrelier. You have to use a different set of equations. And if it gets higher Mach number still, because of the friction, you'll start splitting the molecules of air. And if you go even higher than that, you start stripping the electrons off of the atoms. You see that in when a vehicle is coming back from space. So wind tunnels have been around for a long time. The Wright brothers used wind tunnels extensively. They were probably the first to investigate the shapes of wings and airfoils in wind tunnels so that they could gather data. The Wright brothers, or people who use wind tunnels, we rely on the fact that it doesn't matter if the vehicle is flying through air or if the air is flying over the vehicle. Also, with a wind tunnel, you can test a subscale model, a model of the actual vehicle, maybe a 1/10 of a scale or 50th of a scale, whatever it is. And so you don't have to build up a whole vehicle and test it, right? It's very expensive to do that and not necessarily very safe to do. But if you can test a model of it and you can select the conditions of the air, the temperature you're going to have the air and the speed flowing over, if you can match conditions just right, then the measurements that you take on that model can be applied to the full-scale vehicle. It's a lot cheaper to do that. And there are a lot of different types of wind tunnels out there that test at all the different speed regimes, and they test different aspects of the vehicle. So if you fly in an aircraft today, I can't think of an aircraft that has not been through a wind tunnel of one kind or another. But so for hypersonic speed regime, you're interested in testing things that fly at Mach 5 and above. And those kinds of things are spacecraft that are returning from space and going through an atmosphere. So either Earth's atmosphere or Martian atmosphere, or it's a vehicle that is going where you want to go from point A to point B very fast. Things like missiles. Department of Defense is very interested in ICBMs or high-speed cruise missiles. And also commercial transport, right? Everyone wants to get from here to there faster. If we could come up with a viable means of doing that, then we're going to have to test in that speed regime, that very fast speed regime. When you're working in the wind tunnels, you're working on projects that are very early in their stages of completion. A lot of them don't end up flying because the program gets canceled, or some other reason. In doing the wind tunnel testing, you prove that concept is just not feasible. Well, I've probably tested more vehicles that have not flown than have flown. The dangers are we're working with, high pressure oxygen, high pressure hydrogen. In other words, we're testing the scramjet engines itself. And so they also have a fuel, jet propellant or JP or whatever it is that you're using, rocket propellant maybe. So you also have that stuff, liquid or gaseous, whatever you're using. So a lot of high pressure volatile gases. So we have a lot of safety procedures and processes and checks and balances that we have to go through to make sure that we don't blow something up. And then the test cell is surrounded by 18-inch concrete walls. So even if we blow something up, at least we keep people safe because we're not in there, right? Over the past few years, especially on the military side, scramjet engine development has been a very big thing, because if you can create a vehicle that has an air-breathing engine instead of a rocket, You don't have to take your oxygen because you're breathing your air now, right? It's a lot easier for you and me to breathe air and walk around than it is to strap a tank on our back and go underwater. We have to take our oxygen then, right? But so if you can get an air breather missile, then you can replace that weight that you saved with munitions. So the military is very interested in it. Of course, anytime you design a new spacecraft that's going to have to come back, you need to do the wind tunnel testing. Comes in through the atmosphere so fast that it's going to be flying at hypersonic speeds at some point in its trajectory. And so you're going to have to test for that. All of those probes that you hear about, Sojourner and all of that, they all had a shell, what's called an aeroshell, to protect it as it was coming through the Martian atmosphere to land. That had to be wind tunnel tested at hypersonic speeds.
3, 2.
As long as there is a need to go faster, yes, hypersonics will continue to play a role.